Hello everyone, in this experiment we are going to see the simulation of three-phase voltage source inverter in 180 degree mode of conduction. So what is a voltage source inverter? A voltage source inverter or VSI is a device that converts unidirectional voltage waveform into a bidirectional voltage waveform. So it is also called as, in other words, that is a converter that converts its voltage from DC form to an AC form. So what is a 180 degree mode of conduction? So in this 180 degree mode of conduction, you are having a three-phase inverter. So that is, then each thyristor conducts for 180 degree. So we are having the thyristor pair in each arm. So that is T1 and T4, then T3 and T6 and T5 and T2. So these are turned on with a time interval of 180 degree. So it means T1 remains on for 180 degree and T4 conducts for the next 180 degree of a cycle. So in the 180 degree mode of operation of a three-phase inverter, the two thyristors are conducted at a one time. A single-phase bridge type cycloconverter uses the A type of thyristors. So in this, the application of VSI can be used in the enormous applications such as UPS, so uninterruptible power supply, induction heating, then HVDC transmission lines and adjustable speed AC drives, etc. So it performs the inverse operation of an AC to DC converter. So these are also the two classifications of inverter. So that is called also having voltage source inverter and also a current source inverter. So this is your circuit diagram of a three-phase voltage source inverter with 180 degree mode of conduction. So you are having a continuous power guide, then your DC voltage source, you are giving the amplitude of 24 volt. Then we are having a 6 MOSFET switches. For 6 switches we are going to give the gate pulses. So pulse generator, for first pulse generator we are going to give the value of amplitude 1, period 0.02 seconds, pulse with 50, phase delay of 0 seconds. Then next pulse generator, amplitude 1, period 0.02, pulse with 50, then phase delay is 6.66 e power minus 3. Then pulse generator 2. So amplitude 1, period 0.02, pulse width is 50 and phase delay is 0.01332. Then next pulse, the amplitude 1, period 0.02 seconds, pulse width is 50 and the phase delay is 9.99 e power minus 3. Then for fifth pulse, amplitude 1, period 0.02, pulse width is 50 and the phase delay is 0.01665. Then last pulse, amplitude 1, period 0.02, then pulse width is 50, phase delay is 3.33 e power minus 3. So after finishing giving the parameters to your pulse generator, we are going to connect all the gate pulses, then the MOSFET switches to the three-phase RLC load. So we are using three-phase inputs, so going to connect the load of three-phase. So this is your three-phase series RLC load. So then your output of the load can be seen through your voltage measurement. So the two voltage measurements are given to RMS value. So they can see the output to the display. So after connecting all the circuits, we are going to save the model. Then we are going to run the simulation. So once after simulate the model, we are going to see the output. So this is your output. So we are taking the output from these two values. We can clearly see here. So here the output line can be taken from this one phase. So another one is taken from this phase. So we are taking only two phases. We can take that from the third line phase also. So now just we are taking the two phases. So we are going to see the two phase. So that is for VRB. So this is your output. So here we can see how it is connected. So this is your VRB phase voltage. This is your output. So we can clearly verify that your three-phase VSI, that is voltage source inverter with 180-degree mode of conduction, is verified successfully using your MATLAB simulation. Thank you.